Oh, hi there. Thanks so much for showing up for your learning, everybody. I am your humble math servant, Mr. Jennings, and we are walking through the Introduction to Linear Relations Delta Math assignment. So let's take a look at some graph stories. Who doesn't love a good story? Okay, during a snowstorm. So these we're going to do a lot of reading and then create a graph based on our reading. So Cameron is tracking the amount of snow on the ground. That's great, good for him. When the storm begins, 2 inches of snow on the ground. Okay, so I'm going to put in 2 inches at time 0, because that's time since storm began, so we're at 0 hours from that. And then for the first 4 hours of the storm, snow fell at a constant rate of 1 inch per hour. Okay, 4 hours, 1 inch per hour. We're going to be adding 4 inches of snow. So I'm going to come down here, and after 4 hours, we're going to add 4 inches. That's going to be 6 inches total. Cool. And then, let's see what happens. The storm then stopped for 6 hours. Okay, so for 6 hours, it's going to go from 4 to 10. That's 6 hours. No more snowfalls. I'm building my story here. And then started again at a constant rate of 2 inches per hour for the next 2 hours. All right, so we got 2 hours, 2 inches per hour. So that would be there. All right, oh wait, there to there. Look, it's falling at a faster rate. Cool. And then, as soon as the storm stopped again, the sun came out and melted the snow for the next 2 hours at a constant rate of 2 inches per hour. Okay, so we're going to go from here, and we're going to lose that much snow. That's 2 per hour. As you can see, every hour goes by, we go down 2. So matches the story. All right, this is what we're being asked to do, is create these graph stories. Let's submit. And don't forget to give yourself a pat on the back when you create a nice graph story. All right, I'm feeling like we need to do 2 of those, not 5. So we're going to edit this assignment. If you want, you can refresh your Delta Math assignment. It now only requires 2 of the first question, not 5. And now let's go in. We're going to go Graph Stories Level 2. That one, we're going to say 3 of them. So it's like 5 total. Okay. All right. So let's go back. Let's take a look at Level 2, and we'll discuss how they're different. So we again got a snowstorm here. All right. And Scarlett's tracking the amount of snow on the ground. There was 1 inch of snow to start, so boop. And for the first 8 hours, we had 1 inch every 2 hours. Okay, that's a little trickier. So 8 hours, it was falling at 1 inch every 2 hours. That would be 4 extra inches, because it's half an inch every hour. So we're going to go up to 5 at 8. And that then gives us our 1 every 2. And you can see that on the graph, right? I move over 2 and I go up 1. I move over 2 and I go up 1. I move over 2, I go up 1. So you see that slope on the graph. That's good to build that visual awareness there. The storm then stops for 2 hours and then started again at 1 inch every 3 hours. That's even harder. Okay, stop for 2 hours. So we're going to go here to here. That's stopping for 2 hours. And then 1 inch every 3 hours for the next 6 hours. So that's actually only going to add 2 inches. So it's going to be from there to there. All right, and then if I look in, there is every 3 hours we add 1 inch. Every 3 hours we add 1 inch. So you can see the rate of change on the graph by kind of visualizing triangles along your lines. Make a graph. Okay, let's go. Submit answer. Yeah! All right, we got it. Okay, cool. So do some of those. Then we want to interpret some graph stories. We're going to be shown a graph and then ask questions about it. So here we go. Another snowstorm. I think maybe there's not all snowstorms. On a spring day. Okay, there we go. Time of day and temperature. All right, so we notice that we're starting our temperature at 50 degrees. It goes up to 54. These are in Fahrenheit, so don't worry. People are not actually cooking outside. You could probably cook an egg on the sidewalk if it was 60 degrees Celsius on a given day. Okay, you surely could. Okay, Gavin notes the time of day and temperature in degrees. Temperature rose, stayed steady, and fell at different rates. So we have this graph of temperature over time. At what rate did the temperature rise from 8 a.m. to 5 p.m.? Okay, so here we go. 8 a.m. is there, and 5 p.m. is where it stops up there. So to figure out the rate at which it rises, I note that 8 a.m. to 5 p.m. is 9 hours. Okay, so that's changing by 9 hours. So I'm going to start doing some calculations, okay? 8 a.m. to 5 p.m. We got that's equal to 9 hours. All right. And then how much did the temperature change? Well, it went from 54 to 60. So I'm going to do a subtraction here. 60 minus 54, and that gives me a 6-degree change. We want to think about the unit that we would use here. So I would measure the amount of temperature change in degrees per hour. So since my unit is degrees per hour, that's how I'm going to set this up. So I'm going to have 6 degrees divided by 9 hours, and then note that that reduces to 2 on 3. Okay, so we're rising by 2/3 of a degree every 2/3 of a degree every hour, or 2 degrees every 3 hours. All right, and we would see that if we go in here, and if you look, here we go over and up. Over 3 hours, up 2 degrees. Over 3 hours, up 2 degrees. Over 3 hours, up 2 degrees. So that's where we can see this rate of change on the graph. Let's go. So at what rate did the temperature rise? 2 degrees Fahrenheit every 3 hours. All right, so that's how you interpret a graph story. All right, let's do a new one. Michael left his house and drove to the store. Look at that. He stopped for a little while. He drove again. The graph below shows the number of blocks away from home Michael is. So this is his distance in blocks from home. He drove 25 blocks to go to the store. The store's pretty far away. Okay. All right, and then it's measured in minutes. Which of the following statements is true of Michael at time x is equal to 20? All right, at x is equal to 20, we have it's up there. All right, so that's cool. And he was 5 blocks away from home. So he's driving towards his house at a rate of 5 blocks every 1 minute. That's true, okay? And we can see that in here. Watch. 1 minute will go by from here to here, and he changes position by 5 blocks. So very good. He's going to get home in 1 minute, and that's going to be true. So we want to be able to look at these graphs and interpret the meaning of them. That's cool. Yes. All right. So that's how we do these ones. Okay. And then, one moment. All right, let's carry on. So if we're looking at finding basic patterns in a table, okay, so these ones, we're given a table, and it represents a linear relationship, and we're asked to find the missing value. So the way we would approach these ones is get your paper out. I prefer working with x over here and y over here, so I would organize it this way. 1, 2, 3, 4, 5. And then we have 10, 18, 26, 34, one of my favorite numbers. And now I got to do some analysis here. So I'm going to notice that these are all growing by 1. We're growing by 1 here, so no surprises there. And over here, I can see, if I need to, I can go 18 minus 10 equals 8, and it's positive. So these are growing by 8. I can verify that 18 plus 8 is 26, and 26 plus 8 is 34. And then if I want to know what that number is going to be, I would do 34 plus 8 is, oh, it's 42. 42 is the answer. 42 is always the answer. All right, let's do another. Okay, so this one, I notice that the values are growing by 7 for y, and the x values are growing by 1. 18 plus 7 is 25.
That's it? Yep.
That's it. Okay, 13, 21. Oh, they're growing by 8 again. 29 plus 8 is 37. 37 plus 8 is 45. Okay, cool. So that's how that one do. Okay. Next, we have identifying linear functions from points. Okay? There are a couple different problem types here. We can be given a table, which we've looked at. We looked at that yesterday, and given a set of points. A set of points you could basically organize into a table. Okay, and I'll show you how you would do that with this type of situation. Here, if I've got my x and my y, I'm just going to turn these values into a table here. So when x is 0, y is minus 1, because these are alphabetical, remember? Those are x, y points. Okay? 3, 3, 6, 6, and 9, 9. It doesn't look good. This doesn't look linear, because this one grows by 4 when this one grows by 3. But when this one grows by 3, this one only grows by 3. So the ratio here and here is not the same. Okay? Here it again grows by plus 3, plus 3. So that wouldn't make a line on the graph. This point would be a little bit lower, actually. It would be down there, and then these ones would be on a line. So it's not linear. So we check this one. Okay, so let's scroll up. We'll get some more space. Minus 1, minus 6 is our xy. And then 1, 2. So we're growing by 2 here. And we grow by 8 here. Because 2 minus minus 6 shows us that that's an increase of 8. Or if you think about it like a negative 6 degree day becoming a 2 degree day, the temperature must have gone up by 8 degrees to cross 0. Okay, and then, oh, I wrote that down wrong. It was 1 minus 2. So scratch all that. It only grew by 4. Okay, plus 4. And then the next one is 3, 2. So it's not linear. Because this one, I mean, no, this is growing by 2. And then this grows by 4. And then 5, 6. So that also grew by 4. And this grew by 2. We're asked to find the one linear function. So that by process of elimination, because we found one that's a linear relation, the others won't be. So we'll just submit that. Yay! Good. So let's try one when it's already organized in a table. When it's organized in a table, again, we can just analyze it this way. So here, I'll do it like this. So this one here, x is growing by 2 each time. But y here grows by 2, here grows by 2, and here grows by 2. Because it's consistent, A is certainly a linear relation. The others won't be, just because that's the way they set up these problems. Let's take a look at this one. Here, x is growing by a different amount each time, so it's a little tricky, right? First, x grows by 1, and then x grows by 4, and then x grows by 2. And if we take a look at the way y changes, y grows by 3, and then, by negative 3. Negative 3. And then it grows by negative 6. And then it shrinks by negative 3. Okay, so look at that. X grew by 2 and y grew by negative 3. X grew by 1 and y grew by negative 3. Those are not the same ratio, right? This one is going down by 3 every 2. This one is going down by 3 every 1. That's different. So it's not linear. A is linear in this case, so we'll choose A. Yeah. Hooray. All right, so that's identifying functions from points. Let's take a look at this one. Here we have a weird function, okay? A function just indicates like a mathematical pattern, a relationship between x and y, okay? So, well, it's a special kind of relation. You'll talk about that in grade 11. So, if we're interested in what happens between x is 0 and x is 4, it's this looping negative bit, okay? That goes down. So it's decreasing and nonlinear. It's not a straight line, and it's a negative relation, or it's decreasing. So the language we used yesterday was positive relation or negative relation, but we can also say increasing relation or decreasing relation. So this is decreasing and nonlinear. Yes, let's go. So see, they've identified the region that we're interested in between x is 0 and x is 4, and then they look at the function and see what it is. Okay, let's do another. Okay, so which one is decreasing and nonlinear? Well, I can see here from negative 9, x is negative 9, to x is negative 3, the function decreases in a nonlinear manner. So that's the one between x is 3 and x. Yeah, there we go. So these are the question types that you will do in this one, working on that vocabulary. And then this one, last type of question today. Madeline is driving on a long road trip. She created the graph below to represent gallons of gas left in her tank. Okay, Delta Math is American, so gallons are another way of purchasing and measuring gas. She starts with 11.5 gallons, and after 5 hours, she now has 9.75 gallons. So if we want to know, what does the y-intercept in the graph represent? This is what we mean by y-intercept. For those of you working on your exam, here's a good spot to tune in because there's some new vocabulary that we're going to be talking about here that will help you on the Delta Math and in this unit. So when we're talking about the y-intercept is referring to where the graph touches the y-axis. Another word for the y-intercept is the initial value, because that's where x has the value 0. That's where we start the stopwatch. When she starts her road trip, she has 11.5 gallons of gas in the tank. So that would be the number of gallons of gas initially in the tank is the meaning of the y-intercept, which you would see right there. Let's go. Hooray! Let's go. Okay, an elevator traveling down from the top floor of a skyscraper. All right, and we see that it's going down in a linear manner. Actually, it looks pretty fast, like it goes down 1,000 feet in 40 seconds. Is that like 25 feet a second? Yeah, 25 feet a second seems really fast. Holy. Anyway, and we're asked for what the meaning of the x-intercept is. X-intercept refers to where the graph touches the x-axis. So that's its x-intercept. And at this is telling us where does the height equal 0. Because the height is 0 all along here. Our graph hits that point there. So that's telling us when the elevator reaches the bottom floor, moving at 25 feet a second. So that's how long it takes for the elevator to reach the ground floor. Oh my goodness. Yeah, good. All right, now let's see, what other problem types we got in here? Interpret the y value for given x value. Here's another type of question that you will have. An elevator traveling down from the top floor of a skyscraper, okay, represents its height in feet over time in seconds. What's the meaning of the y value when x is 1? Okay, so here's x is 1, and we go up here, the y value is 637. Okay, so that tells us the elevator's height after 1 second. It's just reading that point. What does that point mean? After 1 second, we've come down to a height of 637. That's all. All right. And then we also have interpreting a point. So, what is the meaning of the point 1? 21.25. Well, if we look at the graph, after 1 week, the height of the sunflower is 21.25 inches. So that's the meaning of that point. A height of this much after 1 week. You have to read the graph and tell what that point means to make the answer go yes. Good. And now let's take a look at x value for a given y value. So here we have a linear relationship between number of times a species of cricket will chirp in 1 minute. So here's chirps per minute, here is the temperature. So that's very interesting that they've set this up where the independent variable is chirps per minute and the dependent variable is temperature. I would flip those. I would think that temperature is independent and it determines the number of chirps per minute. But whatever, that's not what we're testing here. So what's the meaning of the x value and y is 80? Well, if we go up here to 80 and we go across, we find the x value of just about maybe 170, 175 there, okay? And so we would say that's the number of chirps per minute. Oh, 172. The expected temperature in degrees Fahrenheit? No. What's the meaning of the x value? Would be the number of times a cricket could be expected to chirp in 1 minute if it's 80 degrees Fahrenheit. If we're going up here, 80 degrees Fahrenheit, and we go across, we get that point, we're expecting a cricket to chirp that many times. So that's what that means. Yeah. All right, and the last one is interpreting slope. This is the trickiest one. there's a roughly linear relationship between the length of someone's femur, the long leg bone in your thigh, it's the longest bone in the human body, and their expected height as expressed in the graph below, okay? People with longer femurs tend to be taller, all right? And this is the relationship between your femur length in centimeters. People don't have femurs that are 5 centimeters long. Your femur should be like 45 centimeters long, like that. It's long. It's from your hip to your knee. It's like, mine looks like nearly 2 feet. Anyway, whatever. We can still answer their question. Okay. What does the slope of the line represent? So when we're talking about slope here, just copy out our graph. Looks something like that. We are looking at how much does the line change over time. As we increase femur length, how much are we increasing the height of someone? So that's what we're talking about with slope, is what does that rate of change mean in this context? And so the slope would be the change in how tall you are, how tall, based on femur length. As we increase this, how much do we increase that? So these are all the problem types. So I hope that helps you get through this Delta Math and practice all of the skills that we've looked at this week. Any questions, hit me up in class, hit me up at lunch. You can even hit me up in the YouTube comments, although I'll probably see those in 3 years. I sometimes see them very late. Okay, and thank you for showing up for your math learning. Bye for now, everybody.